Here we go. Ready for lesson number 17, common multiples. Let's dive in. Activity number 1 is a notice and wonder. It says, circle all the multiples of 4 in this list. Well, look at all these numbers. We're going to have to find all of those that are multiples of 4. In other words, 4 times 1 equals 4. 4 times 2 equals 8. 4 times 3 equals 12. These are the multiples of 4, right? 4, 8, or in other words, counting by 4s, right? So 4, 8, 12. What's next? 16, 20, 24. Notice it's literally every 4th number. 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We are counting by 4s, okay? So, done with that one. Circle all the multiples of 6. Okay, same idea. We're going to count by 6s. So 6, and then 12, and then 18, and then 24. Awesome. So we did that. What did you notice and what do you wonder? Well, I'm going to get rid of all this extra just stuff that distracts us here. What do we notice and what do we wonder? Well, when we found the multiples of 4, there were 1, 2, 3, 4, 5, 6 of them. Okay, so it was a smaller number and there were 6 of them. With a bigger number, there were fewer of them, right? But there still were 4 of them, so that's something that I noticed. One thing I noticed as I went through here is that some of these were the same. Did you notice that 12s were the same on both lists? And so were 24s, right? So I noticed that those were the same, and I wondered if those mean anything, right? So that's what I noticed and what I wondered. Certainly there's no right or wrong to this question, right? So I hope you wrote down at least one thing that you noticed and at least one thing that you wondered, okay? Number 17, the florist's order. A florist can order roses in bunches of 12 and lilies in bunches of 8. Last month, she ordered the same number of roses and lilies. If she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? Find all the possible combinations. Okay, so I'm going to organize my work here. We've got bunches of flowers, right? She can buy 1 bunch, she can buy 2 bunches, she can buy 3 bunches, etc. Okay, and if she does that, let's have a column here for lilies. If she buys 1 bunch of lily, then it'll have 12 in it, right? If she buys 2 bunches, then that's 24 lilies, etc., etc. We'll keep going with this list in a second, but I want to organize it because we also have, oh wait, that was roses. I messed it up. This is roses are in bunches of 12, and lilies are in bunches of 8. Okay, so 1 bunch would be 8, 2 bunches would be 16, right? Now, we have to keep going until we get to 100. So let's see about this. Let's see how many bunches we're gonna need to get to 100 of each kind of flower, right? We're only at 24 for roses, so let's keep going. If I buy 3 bunches, 3 times 12 is 36. If I buy 4, that's 48. If I buy 5, that's 60. If I buy 6, that's 72. 7 is what, 84? 8 is, what's 8 times 12? 96? Yep, 96. Now, can I buy 9? No, because that would go over 100, right? So there we go. How about lilies? If I buy 1 bunch, again, that'll be 8. If I buy 2 bunches, that'll be 16. 3 bunches is 24. 4 bunches is 32. 5 times 8 is 40. 6 times 8 is 48. That's a 40. 7 times 8 is 56. And 8 times 8 is 64. Uh-oh, I can keep going in the lilies column, can't I? 9 times 8 is 72. Uh-oh, I'm into my blackness. 10 times 8 is 80. 11 times 8 is 88. I mean, I could keep going with lilies, couldn't I? But I've run out of room. Let's see if I actually need those numbers. Let's see if I can answer my questions. If she ordered no more than 100 of each kind of flower, how many bunches of each could she have ordered? Find all the possible combinations. Well, she wants the same number of roses and lilies, right? So let's look for these numbers that are the same. 12 and 8, nope, nope, nope. Let's see, what are the same? What are the same? I see 24s are the same. Do you see anything else that are the same? I see another one. 72 is the same on both lists. Did you see that? Now, we had to stop on the roses because we know it didn't go over 100, right? So even though this one, the lilies, could have kept going, I ran out. So I know there's not going to be any more the same. Does that make sense to everybody? Because I know there was a limit of 100 roses, right? Okay. So there's my same, right? So she could buy 2 bunches of roses and 3 bunches of lilies and get the same number of flowers. Or she could buy 6 bunches of roses and 9 bunches of lilies and get the same number of flowers. Does that make sense to everybody? So she can buy, to get 24 flowers of each, right? She would need 6 bunches of roses. And no, not 6. Oh my goodness, what am I doing? She would need 2 bunches of roses and 3 bunches of lilies. Right? To get 72 of each flower, she would need 6 bunches of roses and 9 lilies. I'm just going to simplify this down because I'm out of room. And 9 bunches of lilies. So there's my answers for number 1. Does everybody see that? I can either buy 24, in order to get the same number of each flower, right? I could buy 24 of each this way, 2 bunches of roses and 3 bunches of lilies. Or I could buy 72 of each and buy 6 bunches of roses and 9 bunches of lilies. Okay. What is the smallest number of bunches of roses that she could have ordered? What is the smallest number of bunches of lilies? Explain your reasoning. Well, the smallest bunch of roses would be 2 at 24, right? So let's see, the first one, what is the smallest number of bunches of roses? Is 2. What is the smallest number of bunches of lilies? The smallest bunches would be 3. See that? Explain your reasoning. Again, because that's what they had in common. 24 flowers, so I would need 2 bunches of roses and 3 bunches of lilies. Okay? Very, very good. Let's move on to the next question. The least common multiple of 6 and 8 is 24. What do you think the term least common multiple means? Well, we know that multiples are all the counting by that number, 6, 12, 18, 24, right? And common, we know it means same. So it must be the multiples of 6 and the multiples of 8 that they have in common, and it must be the smallest of them. Well, that kind of makes sense. Let's try it out. What are the multiples of 6? Well, the multiples of 6 are 6, 12, 18, 24, whoops, and I already messed up, 36. Oh, I missed one, 30, and then 36. That's what I missed, right? And then 42 and 48. Now, the thing about multiples is that they keep going forever and ever and ever and ever and ever. That's why we stop at the least common, because there's no such thing as a greatest common, because numbers never end, right? So let's do the multiples of 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. What am I doing? And I'm going to stop there. So what is the least common multiple? Well, there's nothing common until we get to 24. So they're right. The least common multiple, or the smallest one that they have in common, is 24. So that's what a least common multiple is all about. And you can explain that in your own words. Very, very good. Number 2, find all the multiples of 10 and of 8 that are less than 100. Okay, so it's going to give us a limit. We don't have to keep going forever and ever and ever. Thank goodness. And then find the least common multiple. By the way, a least common multiple has an acronym as well. It is LCM, for least common multiple. LCM. Okay, so let's find the multiples of 10 and of 8. Just like we did with the factors, I'm just going to list these out. Okay, so the multiples of 10, oh, these are easy. 10, 20, 30, 40, 50. Now, when do we stop? We stop at 100, right? So 60, 70, 80, 90, and 100. Stop, because I don't have to go any further. Now, the multiples of 8. Well, we already did those as part of our example up here. So let's just copy those down. 8, 16, 24, 32, 40, 48, 56, but we have to keep going. 64, 72, 80, 88, 96, and that's it, because I can't go over 100. Okay, so there they all are. Now we need to find the least common multiple. So let's find the common multiples first. What do they have in common? Can we see any common? Oh, I see 40. Any other common ones? Oh, I see 80. Did I miss any? Normally, I'd have you guys yelling out at me right now, and since I don't have you yelling out at me, it's harder to do this problem, right? I'm used to having you guys yell at me. But I think I got them all. Now, which of these is the least or the smallest? That would be 40, right? So the LCM is 40. I'm just going to circle that right there as my answer. The least common multiples of 10 and 8 is 40. Very good. Number 3. Find all the multiples of 7 and 9 that are less than 100. Okay, good. They let us stop. Find the least common multiples of 7 and 9. So we're going to do the same thing here. 7 and 9. Help me out. See if you can do these with me. The multiples of 7 are 7, 14, 21, 28, 35, 42. Oh my goodness. 49, 56. What am I? That's 7 times 8. 7 times 9 is 63. 7 times 7 is 70. 7 times 11 is 77. This is going to go on forever. 7 times 12 is 80. 7 times 12 is 84. 7 times 13. This is why I need my multiplication chart. If you guys have your multiplication charts, pull them out. How helpful would they be right now? What is 7 times 13? Well, it's going to be a 1 and a 7 times 91. No, 7 times. Oh my goodness gracious. I don't know what the next one is. What's 84 plus 7? 91. Yeah, 91. Plus 7 is going to be 98. I'm going to squish those in here. So 84 plus 7 is 91. And then 98. Wow. Oh, goodness. And then plus 7, I'm going to be over 100, so I can stop. Now the 9s. Here's the real test. Do I know my 9s multiples? Here we go. 9, 18. 9 times 3 is 27. 36, 45, 54, 63, 72, 81, 90, and 99. Oh, hallelujah, they ended sooner. Okay, because I don't have to go past 100, so I know I'm done. Now, let's look for the common multiples. Does anybody see anything that they have in common? As I was going through, I did hear myself say the same numbers a couple of times. Let's see if I can find any of those. 63 is common. Do we see any others? And my dog is going crazy. I think he likes common multiples as well. Go outside, Doobie. What's common? I wish I could hear y'all yelling at me. I don't see anything else, do you? I think 63 is the only one. So since it's the only one, it is the LCM. So we're done with number 3. Well done, well done. Now, this Are You Ready for More, of course, is optional. I would love you to give that a try if you would like the challenge problem. All right, our last activity today, prizes on grand opening day. Let's do this. It says Lynn's uncle is opening a bakery. On the bakery's grand opening day, he plans to give away prizes for the first 50 customers that enter the shop. Every 5th customer will get a free bagel. Every 9th customer will get a free blueberry muffin. Every 12th customer will get a free slice of carrot cake. Wow, that's awesome. Sounds like a lot to keep track of, though. Number 1, Diego is waiting in line and is the 23rd customer. He thinks that he should get farther back in line in order to get a prize. Is he right? If so, how far back should he go to get at least one prize? Explain your reasoning. Wow. So this is obviously going to be a least common multiple problem because, hint, hint, it's in this lesson, right? So let's think about how this could be a least common multiple problem. Well, it says every 5th customer. That sounds like multiples of 5, doesn't it? So the 5th customer, the 10th customer, the 15th customer, those are multiples of 5. So what if I were to find all of the multiples of 5? Then I would know who got the bagel, right? Okay. Well, every 9th customer gets a blueberry muffin. So what if I were to find all the 9th customers, right? 9th, 18th, right? All of the multiples of 9. And then it says every 12th customer will get a carrot cake. Oh, so let's do muffin here. And then cake here. Every 12th customer will get cake. Okay, so we got to figure out, where does Diego need to be in line to get at least one of these, right? Okay, so to get a bagel, he would have to be the 5th customer, the 10th customer, the 15th customer, the 20th customer, or the 25th customer. Well, right now he's the 23rd. So if he goes back in line 2 places, he would get a free bagel. So I think he's right. To get a bagel, he just has to scoot back, just nonchalantly step back behind 2 people, and then he'll be 25th in line. Look at that. Now, where would he have to go in order to get a muffin? Maybe he doesn't like bagels. Maybe he really wants a muffin. Where would he have to be? Well, let's figure those out. 9th place in line, the 18th place in line, the 27th. There's our first chance. If he's the 23rd, if he goes back 4 more places, he could win a muffin. Now, we can't go forward, right? We can't go to the 18th spot because we don't want to butt in line, right? So the only way we can do this is to go back, because then people won't be as mad, right? Okay. So there we go. If he really wants a muffin, he'll have to go back 4 places, right? But what if he really wants a piece of that? What was it? What kind of cake? Carrot cake. What if he just is dying for carrot cake? Let's find out how far he'd have to go. Well, the multiples of 12 are 12, 24. Ooh, he only has to go back 1 spot. That's the most likely. Oh my goodness. He could easily just nonchalantly let one little old lady go ahead of him, and then she would not get a piece of cake and he would. How mean is that? Oh my goodness, Diego. Okay, so let's answer our question. He thinks that he should get further back in the line in order to get a prize. Is he right? Yes, he's right. Yes, he does need to move back. If so, how far back should he go to get at least one prize? Well, to get 1 bagel, he would have to move back 2 spots, right? From 23rd to 25th, that's 2 spots. To get a muffin, he would have to move from 23rd to 27, so that's 4 spots. And to get a cake, he would have to just move 1 spot. Okay, so I think we actually answered more than we needed to, right? I think really all we needed was this first one. But now we know we have some options, right? Depending on which one he wanted. He could move either 2 spots and get a bagel. He could move 4 spots and get a muffin. Or he could move 1 spot and get a cake. Jada in number 2 is the 36th customer. Will she get a prize? Well, I don't know because we didn't go far enough. Should we keep going? I'm going to move this yes so that I have a little bit more room. I'm going to put my yes over here. Okay. So 25 and then 30 and then 35 and then 40. Does 36 get one? No. She will not get a bagel. Okay. So far, no. Muffins, 9, 27, 36. Yes. She will get a muffin. Yes. A muffin. Will she get cake? Yes, actually, look at that. The next multiple of 24 is 36. And cake. Wow. Is it possible for her to get more than one prize? Yes, we just found that out, right? Yes, a muffin and a cake. Explain your reasoning. Because they had those multiples in common, didn't they? She has both multiples in common. Wow. How many prizes total will Lynn's uncle give away? Oh my goodness. Now that is tricky. Let's see. I am running out of room. I'm actually going to rewrite this problem up here, down here, so that we can go even further, because I've kind of gotten in my way with my answer here. So let's do this again. To get a bagel, I'm just going to call it B. That's 5. Every 5th person gets that, right? So that's 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Now remember, if we go back to our story, only the first 50 customers get a prize. So we stop at 50, right? So that's good. We don't have to keep going forever. For a bagel, that's where it stops. For a muffin, we have to do every 9th customer. So that's 9, 18, 27, 36, 45, 54, 63, 70. Oh, we have to stop. I didn't stop at 50. We stopped right there, right? Because only up to 45 can get a muffin. And then what is left? A cake is the 12th customer. So 12, 24, 36, and 48 is as far as we can go on that one, or else we're over 50. Okay, so how many prizes will he give away? Well, I'm going to circle all of the pot. Well, actually, we just need to count them. We would circle everything, right? How many total prizes will he give away? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 prizes. Does that make sense? Because, as my explanation, there are 19 multiples of each number. Right? We found all the multiples and there were 19 of them. So 19 times during those first 50 customers, he will be giving away a prize. That is super awesome. Very, very good. And that is the end of our lesson. There's our lesson summary page. And we did have 2 new vocabulary words today. Common multiples, again, all those multiples that they have in common or they have the same. And then the least of those is the LCM, the least common multiple. Again, those glossary definitions are super great and they have super great examples. So if you need a little bit more help on those, you can look at the glossary in the very back of your workbook. And now, ladies and gentlemen, we are ready for our homework. And this is a horrible copy of the homework page. So I'm actually going to go and reprint this real fast. While you're working on your homework, I'm going to go make me a new copy of this. So we'll meet back here in just a few. Good luck on your homework. Do your very best. And as always,
do your because you deserve your best.
All right, here we go, diving into practice problems for lesson 17, common multiples. Here we go. Number 1, a green light blinks every 4 seconds and a yellow light blinks every 5 seconds. When will both lights blink at the same time? Okay, so this is a common multiple, right? We need to see when will these blink at the same time. So I'm going to do my work up here above. I need the multiples of 4 so that I know when that light is blinking. And I need multiples of 5 so that I know when that light is blinking. And I'm going to look for when they're the same, because then that's when it'll blink at the same time. So the multiples of 4 are 4, 8, 12, 16, 20, 24, 28. I don't know that I'll have to go any further than that. What do you guys think? I think I can probably stop right there. The multiples of 5, of course, are 5, 10, 15, 20, 25, and 30. I think we've already found our common. Right there is a common multiple. Is there one sooner than that? Nope, that's our first one. So when will they blink at the same time? Every 20 seconds they will blink at the same time. Well done. Part B, a red light blinks every 12 seconds and a blue light blinks every 9 seconds. When will both lights blink at the same time? Once again, I need the common multiples of 12 and 9 this time. So 12 and 9. Oh, by the way, I was going to mention, while I printed this worksheet again, as I told you, the last one was nasty. You saw that. I also printed a multiplication chart, and I wanted to point this out because I also put this on Canvas. I made it nice and big because when we're doing common multiples like this, it's really great to use this because what are the multiples of 8? Well, they're 8, 16, 24, 32, 40, 48, 56. Then when you get up into these higher numbers, they give those to you as well, right? So this is a great tool to use to help you find the multiples of whatever number you're looking for. Just go straight across the rows and those are the multiples, okay? So that is available to you. I may have to use that. I don't know, but maybe. We'll see how I do here, right? All right, so back to what we were doing. We want the multiples of 12. Well, I know that they are 12, 24, 36, 48, 60, 72, 84, 96, and maybe I can stop there. Let's see if I can find a multiple of 9 that matches. 9, 18, 27, 36, 45. Have I found one already? I think I have. I think I spotted 36. 36 is the same. So when will they blink at the same time? Every 36 seconds. So there's the answer to part B. Explain how to determine when 2 lights blink together. Well, it's finding that least common multiple, right? Find the LCM, or the least common multiple of both lights, right? Or their numbers, right? So if I find the LCM of those, that's when they're going to blink at the exact same time, aren't they? Very, very good. Number 2. List all the multiples of 10 up to 100. Oh my goodness gracious. Hopefully we know these. The multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. List all the multiples of 15. Okay, here's where I'm going to need my chart. What a great thing this is. Here they are, very last one. They are the multiples of 15. 15, 30. I want to see how far I can go without looking. 45, 60, 75. That's as far as I can go. 90, 105. Up to 100. Okay, we can stop. I didn't even need 105. Okay, so I did pretty good without looking. How did you guys do? That was very handy though, wasn't it? All right, so there's the multiples of 15 up to 100. What is the least common multiple of 10 and 15? All right, let's look for something they have in common. I see it right there. 30. So the LCM is 30. There we are, number 2. How did many of you got that one right? I hope so. Let's look at number 3. Cups are sold in packages of 8. Napkins are sold in packages of 12. What is the fewest number of packages of cups and the fewest number of packages of napkins that can be purchased so that there will be the same number of cups as napkins? Oh, man, I like this problem. It's like the hot dog bun problem. Have you ever run into that problem where hot dogs come in packages of 10 and buns are only in packages of 8? What were they thinking when they did that? This is the very same thing. If I have people coming to my house, I need the same number of cups as I need napkins. Oh my goodness. People are crazy how they package things up. Let's tackle this one. What we need to know is when will they be the same? In other words, when is the least common multiple of 8 and 12? So let's do this. Well, in packages of 8, if I buy 1 package, that's 8. If I buy 2 packages, that's 16. 3 will give me, 3 will give me 24. 4 will give me, 8 times 4 is 32. 5 will give me 40. I think that I probably have enough. Let's see. If I buy 2 packages of napkins, 1 package will be 12, of course. 2 packages is 24. 3 packages is 36. I think I've already found my number, 24. Right? Now, here's the thing. 24 is the common number, right? So how many cups and napkins will there be? Part B, there will be 24 of each. Does that make sense? But to answer part A, what is the fewest number of packages of cups and the fewest number of packages of napkins? We have to think, okay, these are the multiples of 1, these are the multiples of 2, and these are the multiples of 3. Or 1 package, 2 package, 3 packages. 1 package, 2 packages, 3 packages. Okay, so I'm going to have to buy 3 packages of cups, right? This is cups, and this is napkins. I'm going to have to buy 3 packages of cups and I'm going to have to buy 1, 2, 3. Oh, it happens to be this. No, just kidding. This is my number. 2 packages of napkins and 2 packs of napkins to answer part A. Does that make sense to everybody? If I buy 3 packages of cups, I will get 3 times 8, 24 napkins, or 24 cups. If I buy 2 packages of napkins, that'll be 24 napkins. So how many will I get of each? 24. If I buy 3 packages of cups and 2 packages of napkins. That's like a tongue twister. My goodness gracious. Hope that I was not too confusing on that. Number 4. Rectangle ABCD is drawn on the coordinates. Okay, you know what? We're going to throw out number 4 because this is one of the problems from a lesson that we skipped. So everybody put a great big X through number 4. Put an X through number 4. And hopefully you noticed that in Canvas, that this was one of the ones we were not going to do because we skipped those lessons. Okay? All right, here we go. Number 5, our last problem. A school wants to raise $2,500 to support its music program. If it met 20% of its goal so far, how much money has it raised? So we need to find 20% of $2,500 and find out what that is. Well, let's just write that out. We need to find 20% of $2,500 and find out what that equals. Well, I know how to do that because I know how to change these words into math. 20% is 0.20. Of is multiply. And 2,500, of course, you just multiply that out and I get my answer. So what's 2,500 times 0.2? Well, what's 25 times 2? That's 50. But of course I have 2 zeros, right? But then I have a decimal place. So it's actually going to be $500. Does that make sense? So $500 is my answer for part A. I'm going to put that, well, it's kind of squishy in here. I'll just leave it right here. $500 is my answer for part A. I'm going to make that arrow look like it's actually going to part A. Okay? Part B, if it raises 175% of its goal, how much money will the music program receive? Oh, wow. So if they earned erase. Erasers are great inventions, aren't they? 175% of their goal, which was $2,500, what would that equal? Well, exactly the same process. 125% is 1.75 of is multiply, and then 2,500. Now this one, I'm going to go ahead and do the math, okay? I'm going to do it over here on the side. 2,500 times 1.75. Of course, those are 0. 0 times 0, and this is 25. 5 times 2 is 10, 11, 12. And then I have a placeholder. 7 is going to be 2 more zeros, 0, 0. And then 35. This is now a 3. 7 times 2 is 14, 15, 16, 17. And I'm squishy over here. Then 2 place values, 2 placeholders, and then 2 more zeros, and then 5 and 2. So 5 and 2. Okay, got kind of squishy, but we got it. 0, 0, 5, 7, see 7, 8, 9, 10, 11, 12, 13. Carry the 1. And that was a 1, 2, 3, 4. All right, and we have 2 decimal places, so it goes right there. So it looks to me like it's $4,375. So I'm going to rewrite that. $4,375 is how much they earned. Wow, that's pretty good earnings for their school music program. Very good. And guess what, ladies and gentlemen? We are done with lesson 17. Those practice problems went pretty fast, especially since we got to skip one. So congratulations on this. Hopefully you feel good about least common multiples and are ready for your Check Your Understanding quiz. Dive on into that, and you know what's coming. You are used to this by now. Miss Weird, Miss Hatch, here it comes. As always,
do your best because you deserve your best.